All right, lesson 9 is on energy and work. Now, when I think about energy, first thing I think of is I have a dog. His name's Bowser. This is him, actually. This isn't usually what he looks like. This is him standing still, which never happens. He usually looks like this little guy, who's running around full tilt, kind of crazy. But that's what I think about when I talk about energy. What is energy? That's exactly what I think of, having the ability to do that. And now work is something scientific that's kind of tied in with that. So you notice here, this guy's doing a lot of work. This little ant here is probably doing a lot of work. But how do we define it? So first we'll talk about energy. Energy is the ability to do work. So it's the ability to do something. Okay, cook something on the barbecue, over an open fire. This little guy's rubbing two sticks together. I don't think he's got the right theory, but he can still work on it. It's not really just going to work getting paid. Work in a scientific sense is the transfer of mechanical energy from one object to another. So you're taking energy from one thing and moving it to something else. We can also define it as energy transferred by a force. Now, in this class, what we're going to use work for is we're going to calculate work using two things. Okay, force is the first, and the distance is the second thing. So if we look at our definitions here, we have each of those things. Work we already talked about. So the force is a push or pull on an object. I'm either pushing on it or pulling on it to change its location. And we measure that in newtons. Newton, or capital N, is the unit that we'll use for this, is a measure of force. So, for example, if I pushed on my desk, it's going to take more newtons to move my desk than it is to if I were just to push on my Kleenex box, because it's, of course, lighter. Now, the second part of this, delta D, delta just means a change in, so delta D means a change in distance. Okay, we measure that in meters. So if I push on something and it moves it 1 meter, that's the unit I'm going to use. Okay, now, for work to occur, three things must be met. There must be a force, so something's got to be pushing or pulling. There must be movement. Okay, no work has been technically done unless something moves. And the force and the distance must be in the same direction. Okay, so when we do any practice problems, it's really important that you show all of your work. Okay, now, depending on who your teacher is will depend on how it's marked. Usually, there's things that you need to show me. You need to show me what information you took out of the practice problem. You need to show me the formula. You need to show me work and an answer in significant digits and with correct units. Okay, a crane loading a ship exerts a force of 24,500 newtons. Okay, now that, we know it's in newtons, so we know that's the force. Does that on a crate to lift it 22 meters. So that's got to be a distance. Okay, so we're going to write down what we're given. See on the side here, given what we need, the required part, analysis, solve, and paraphrase. Okay, so we know the three parts of our formula. Let's write it down. Okay, our work, force, and distance. Okay, our force, 24,500. Our distance, 22 meters. Okay, so that's what we have. It asks how much work did the crane do. So that's what we're trying to find out. So we write down our formula. Okay, work equals force times distance. I don't really care if you put the delta in there. Make sure that you ask your teacher to make sure that if they want it or not. Let's substitute our values into our formula. So work equals the number for our force that we're going to substitute in, 24,500. Now, you can either put a dot to tell me you're multiplying. You can make brackets to tell me you're multiplying. But please don't put a times symbol. Okay, that gets mixed up when we're doing rearranging of formulas. We're either going to put the two numbers beside each other or put a dot in between them. We're not going to use a multiply symbol. So, times 22. Okay, now we have our work done. We have our formula. We have our work. Now all we have to do is the multiplying part. So 24,500 times 22, our answer here, 539,000. Now we're not quite done. We need to change this and put it into significant digits. Right now we have 6 numbers up here, 3 of which are significant. But if we look at what we started with, our force has 3 significant digits, our 2, our 4, and a 5. Our distance that we started with has 2 significant digits, a 2 and a 2. So our final answer can only have 2 significant digits. That's our 5 and our 3. Okay? Now if we look at our last number, we also have a 9 after our 3. That means we're going to have to round our next number up. Okay, so first, what we're going to do, we're going to change this to scientific notation and then round it up like we need to here. So let's change it first. We put our pen at the end of our number, or where we expect our decimal point to be. Move it over so that it's after our first significant digit, and count how many we go over. So 1, 2, 3, 4, 5. So in just significant digits, 5.39 times 10 to the 5th. And we can only have 2 significant digits, so we have to round this number up. So we end up with 5.4 times 10 to the 5th. So now, it's not always going to be the case where the question asks just for the work. They could also possibly ask for the force or the distance. If you're given the work, sometimes they'll do that, and you have to rearrange the equation to either solve for force or solve for the change in distance. So we're going to rearrange the equation to make sure that we have the formulas for those as well. So it's the exact same thing as when you rearrange an equation before. We did this in grade 8. You start with your formula first. So work equals force times distance. Okay, and in this case we want to solve for F. Okay, our force. That's what we're looking for in the equation, or that's the part that we don't have. So what we need to do is we need to get F on one side of the equation all by itself. Right now it's being multiplied by the distance. So what we need to do is we need to get rid of the distance part. Right now it's being multiplied. We're going to use opposite operations. The opposite of multiplying is dividing. So we're going to divide this portion, or this part of the formula, by D. What we do to one side, we must do to the other, okay, to make sure that everything stays balanced. Okay, if I multiply something by a number and I divide it by a number, they cancel each other out. Okay, so what happens is we end up with force by itself on one side, and that's going to equal work divided by distance. So all we did was we rearranged this equation to solve for force instead. It's the exact same equation, we just changed it. Now we can do the same thing if we want to rearrange for our distance. We'll use a different color this time. Okay, we're going to start with our same formula, and you don't need to memorize these, you just need to know how to rearrange an equation. And what we're going to do, we need to get D by itself. It's just the same as we just did before, so we have to get rid of our F. Now our F right now is being multiplied, so we're going to do the opposite. Opposite of multiplying is dividing. So we're going to divide by F, cancel that one out. What we do to one side, we must do to the other. Okay, so work divided by F, we did the same thing. These two cancel each other out, and so we're left with distance equals work over force, or work divided by force. So these are those two formulas that you can use if the question asks you to solve for force or solve for distance. What we're going to do is we're going to try it out a couple times just to make sure that we've got a grasp on it. Okay, so for the first one here, remember we need to make sure that we identify the stuff that we've got. We need to know what formula we're going to use, and then we're going to use it. Okay, 1 mark for the work, 1 mark for the formula, 1 mark for the answer, with correct units and significant digits. So for the first one, how much work is done by the jets on a plane if they apply a force of 568,000 newtons to move the plane 12 meters? So in this case, Newtons tells us that that's the force that's being used. Okay, it's moving 12 meters, so that's the distance, and it asks how much work is being done. So work is the part we don't know. Force is 568,000 newtons, and distance is 12 meters. So we're going to write down our formula to solve. Okay, work equals force times distance. We don't have to change anything. This will work just fine. So we're going to now substitute in what we don't, or what we have. Okay, substitute in our force and our distance. So 568,000, and I'm going to use brackets to show that we're multiplying. So times 12. This ends up to be 6,816,000. Now, again, we need to change this and put it into significant digits. We put the formula down, we wrote down what we have, we showed some work, but our final answer needs to be in significant digits. So, we look at our two values that were given at the start. We have 3 significant digits in our force, and we have 2 significant digits for our distance. So we have to make sure our final answer only has 2 significant digits. That's going to be our 6 and our 8. If we look at our next number, it is 4 or less, so the 8 is going to stay the same. Okay, so if we write this out as a final answer, I'll start where our decimal would be and move over 1, 2, 3, 4, 5, 6 points. So 6.8 times 10 to the 6th, and our units are going to be in joules. Now for our second question, we are given something in joules, so we know that's going to be our work. Was done to move in penguin 65 meters. 65 meters is a distance. Okay, so the things that we have here, 53,000 is our work. We don't have a force, and our distance is 65 meters. So that means we're going to be solving for F, or for our force. So we're going to use our force formula. Force equals our work divided by our distance. We're going to substitute in what we have. So force equals 53,000 divided by 65, and we end up with 815.38, etc. Please make sure that you don't round right away, because afterwards they may ask you to do something else. Write down as many numbers as you feel comfortable, usually 2, 3, 4 after the decimal, and then we round it afterwards. So this is our rough answer. We have our formula. We have our work. So far we have 2 out of 3. Now we need to change it and put in significant digits. So we look at our numbers that we were given. 53,000 has 2 significant digits. 65 has 2 significant digits. So what we need to do is change our answer so that it only has 2 significant digits. The first 2 numbers are 81. Our next number is a 5. So that means we're going to round up. Our answer here can either be 820. This only has 2 significant digits. Or, also okay, would be 8.2 times 10 to the 2. Remember to include your units. Force always has units of newtons. So now, for the next 3 questions, what I would like you to do is answer them. We're going to be going over them tomorrow in class. You need to include your formula, your work, and your final answer in significant digits. So number 1, how much work does Batman do when he carries Rachel with a force of 650 newtons, a distance of 12 meters? The second question, if it takes Hercules 5,300,000 joules of work to push this boulder 15 meters. How much force did he have to apply?